A regional insurer decided to automate its claims intake workflow. The vendor demo looked clean. The claimant submits a form, the agent reads it, queries the policy database, checks for duplicate claims, flags anything requiring adjuster review, and routes the rest to payment processing. 6 weeks into production, the operations team noticed something. Legitimate claims were sitting in the adjuster queue for 5 days on average. Nobody had programmed the agent to do that. Nobody had programmed it not to do that. Not to. The orchestration logic had no concept of priority. Every flagged claim, whether it was $200, with a $200 windshield or a $200,000 liability dispute, entered the same queue in the same order. The agent was doing exactly what it was built to do. The problem is nobody had built it to understand the difference between the delay that costs $50,000 and a delay that costs a relationship. That's not a model problem. That's an orchestration problem. And it is the kind of problem that only becomes visible after you understand what an agent is actually made of. This is what an agent is made of. Agents, Part 13. The ingredients list is short. Assembling them correctly is not. Section 1. 3 things called agent. Before we talk about what an agent is made of, it helps to know what one actually does. Some agents are assistants. They read your email, draft a reply, flag what needs attention. Some are autonomous processors. Raw material goes in, finished output comes out. No human in the loop. Some are workflow engines. They collect inputs from multiple sources, apply logic across all of them, and trigger downstream actions across systems that do not control. Same word. 3 very different degrees of complexity, training, and trust required to deploy them safely. This article focuses on the third category. Workflow automation agents are where the real architecture weight lives. They are also what most enterprises are actually trying to build when they say they want an agent. The assistant and the autonomous cases are simpler by comparison, and everything that applies to a workflow agent applies to them by reduction. Section 2, the ingredient list. This list is 6 items. What changes across use cases is how each ingredient is configured, constrained, and connected to others. The model is the reasoning engine at the center. It reads the current state of a task, decides what action to take next, and interprets the result before deciding what comes after. In a workflow agent, the model is not generating content. It is making sequential decisions across a multi-step process involving systems it can only reach through tools. Model selection for a workflow agent is not about benchmark performance on reasoning tasks. It is about instruction following, tool call accuracy, and behavior under ambiguity. A model that improvises creatively when instructions are unclear is a liability in an automated workflow. You want a model that escalates when it does not know, not one that invents a plausible sounding path forward. Memory is how the agent retains context across the steps of a task and across sessions. Without it, every tool call happens in isolation. The agent cannot reason about what it already tried, what the results were, or what constraints it established earlier in the same workflow. Workflow agents need 2 kinds. Working memory holds current task state, what step the agent is on, what it learned from the last tool call, what it is waiting for. Long-term memory holds persistent information across sessions, prior decisions, established patterns, user preferences. Most first builds get working memory right and skip long-term memory entirely, then wonder why the agent treats every session as if nothing happened before. Tools of the agent's interface to the world outside the model. Every real-world action the agent takes, reading a database, calling an API, writing a record, sending a notification, happens through a tool. The model decides which tool to call, with what parameters, and what to do with the result. The prompt is the agent's operating charter. It defines the agent's role, the scope of its authority, the vocabulary it uses to describe the system it works with, and the boundaries it operates within. A workflow agent prompt is not a chatbot system prompt. It is closer to a job description combined with an operating procedure. In a workflow agent, the tool set defines the blast radius. A model that can only read data can only make recommendations. A model that can write records, trigger payments, and send extra communications can cause real damage if its reasoning goes wrong. Tool design is where you make the agent conservative or capable. That is a deliberate decision, not a default. That is 6 ingredients: model, memory, tools, prompt, orchestration, and guardrails. What changes across each use case is how each is configured, constrained, and connected to the others. The rest of this article goes deeper on the 3 that most implementations get wrong. Section 3, the orchestration. The orchestration layer is the component most people underestimate and most vendors undersell. It manages the loop, model decides, tool executes, result returns, model decides again. It also manages everything that can interpret that loop. errors, timeouts, ambiguous results, cases the model was not trained to handle, and the question of when the task is actually done. The claims intake agent in the opening scenario had a working loop. What it lacked was orchestration logic that understood priority, queue management, and escalation thresholds. The loop ran correctly, the workflow failed. Those are different problems. Orchestration is also where you implement human-in-the-loop checkpoints. Not every decision should be fully automated. The orchestration layer defines what decisions require human confirmation before the agent proceeds, and what happens if the confirmation does not arrive within a defined window. Section 4. What keeps it from going sideways? Guardrails are the constraints that define what the agent is not allowed to do, regardless of what the model decides. They operate independently of the model's reasoning. A guardrail that prevents the agent from modifying production records without a confirmation step does not care what the model thinks the right action is. It enforces the constraint before the action executes. Guardrails exist because model reasoning is probabilistic. A well-configured model will make the right decision most of the time. Guardrails handle the cases where it does not. In a workflow agent touching financial records, customer data, or external communications, the cost of a single wrong action without a guardrail in place can exceed the value of everything the agent delivered correctly before that point. Section 5. The prompt is the job description. The prompt is the agent's personality, the guardrails, the language, the tone, and the colloquialisms that make it unique to the environment where it is deployed. The prompt is the only ingredient that requires no engineering skill to get wrong and no engineering skill to get it right. Every other component has a specialist behind it. The prompt is written by whoever understood the job best, or whoever happened to be in the room. That asymmetry is why it causes more production failures than any component it touches. Most agent failures that get attributed to model quality are actually prompt failures. The model is reasoning correctly within the frame it was given. The frame was wrong. Getting the prompt right means being specific about what the agent should do, explicit about what it should not do, and precise about how it should handle ambiguity. Vague prompts produce agents that improvise. Improvisation in automated workflows is rarely what you wanted. Section 6. The ingredients interact. The 6 components are not independent. A strong model with weak guardrails is dangerous. A well-designed tool with poor orchestration logic produces an agent that does the right things in the wrong order. Memory without a clear data model produces an agent that accumulates noise alongside signal. Understanding what each ingredient does is necessary. Understanding how they fail together is what separates a production agent from a demo. The next article covers the team you need to assemble these components correctly, and why the skills required are not the ones most organizations assume they already have.